Hi, welcome all of you to another maths lesson. I am Yasar Arafath. I hope you all understand my videos. If you didn't subscribe my channel yet, please consider subscribing and sharing and liking my videos. In this video, we will continue the topic criterions for similarity of triangles. In the last few videos, we discussed SSS criterion, AAA criterion and SAS criterion with proof. And today we will discuss some questions, some problems on this topic. We want to solve these problems using the criterions of similarity. Let's start.
Look at the first question, very simple question. In the picture, you can see given PQ is parallel to RS. PQ is parallel to this RS side. Prove that triangle POQ is similar to, you know the symbol, right? Triangle POQ is similar to triangle SOR. Can you prove it? Can you prove? How we can prove? By criterion 1 or criterion 2 or criterion 3?
AAA.
Yes, okay. AAA we can apply here. Okay, look here. Given that PQ is parallel to RS, then you know the idea of transversal. When a transversal cuts parallel lines, alternate angles will be equal, right? These two angles will be equal, right? Angle P and angle S, right? Angle P is equal to angle S, right? So when one transversal cuts parallel lines, these angles, how you name these angles?
Alternate
angles, right? Okay, so angle P is equal to angle S you will get, and also second pair, what's the name?
Angle Q equals angle R.
Yes, angle Q is equal to angle R. What about the third angle?
Angle POQ.
Yes, they are also equal, right? Because they are opposite angles. Okay, so actually two angles, if they are equal, then we can say by AA similarity criterion, these two triangles will be similar. Okay, so their sides are different. Their size, you can see in the picture itself, POQ is a little bit smaller than the second one, but here the angles are equal. Since the angles are equal, by you can write it by AAA criteria or AA criterion, these two triangles are similar. You use this symbol. Okay, so we move to next question. Okay, look here. Given the side lengths of these two triangles, we want to find angle P, the measure of angle P. Okay, so here we want to apply the idea of similarity. What will be the third angle here in the first triangle first? 40, right? Because the sum of these angles must be 180. So two angles, the sum makes 140. So the third angle must be 40. Okay, just mark it there. Now look here. Which criteria we can apply to prove that these two are similar? 1, 2, or 3?
SSS.
Yes, SSS. SSS means the second one, right? SSS. So because AAA we cannot, because for the second one the angles are not given. So AAA we cannot apply here. And the third one, there's no angles given in the second triangle. So here the sides are given. So the second criterion, that is sides are in the same ratio. I think we can find the ratio here, and if they are same, we can apply the similarity idea to answer this question. Okay, so how will be the ratio? So you look at corresponding sides.
1:2.
Oh yes, right. 1:2 is the ratio. Look, the corresponding sides you want to take. There is smallest sides in these two triangles. Which are the smallest sides? 3.8 is the smallest in the first triangle. In second, which is the smallest?
7.6.
7.6. Okay, that is AB by QR. What will be this ratio if you reduce 1/2? And second one, the middle side, that means not smallest, not largest. Okay, that is AC divided by in the second picture PR. How will come? 3 root 3 by 6 root 3. What will come? Root 3, so you can cancel, then 3 by 6 reduced to 1 by 2, right? 3 by 6 you can reduce to 1 by 2. And similarly, I think no need to write the third one. BC by PQ, what will come?
6 by 12.
Yeah, 6 by 12. That is also 1 by 2. So here, since the SSS criterion is satisfied, that is the three sides in the first triangle are in proportion with the sides of the second triangle, we can say these two triangles are similar. If they are similar, the corresponding angles will be equal. In other terms, the angles opposite to corresponding sides will be equal. So AB corresponds to PRQ here, the smallest sides. So AB, the angle opposite to AB in the first picture is 40. So the angle opposite to QR in the second triangle should be 40. Okay, so that's what our answer. Angle P is equal to 40 degree. Okay, well, how much will be angle R here? 80, right? Because the corresponding angles. So here in the first triangle, the largest angle is 80. So in the second picture, the largest is angle R. So that must be 80. In other way, the angles opposite to corresponding sides. So the angle opposite to the largest side 6 in the first triangle is 80. So the angle R opposite to largest side of the second triangle must be 80. So this will be 80 and the third angle will be 60 each. Okay, that's all. Okay, one more question I think we can do fast, then we can wind up. Okay, look here. Here the question I shall write here. Question is like this: given AO into BO, AO into BO is equal to DO into CO. This is given. And we want to prove that these two triangles are similar. Triangle AOD and COB are similar. Can you prove? Given AO into BO is equal to DO into CO. Can you prove these two triangles similar? By which criterion, if possible? Right. SAS, right? Okay, SAS. How? Here we can rearrange this given equation. AO into BO is equal to DO into CO. How we can rearrange? Take AO by CO. AO by CO is equal to
DO by BO. Okay, we got AO by CO is equal to DO by BO. And also look in the picture. Here angle AOD and angle COB are opposite angles. They are equal. And AO by CO is equal to DO by BO. That is the condition for SAS, right? One angle equal in these two triangles and the sides including these angles are in the same ratio. AO by CO is equal to DO by BO. Therefore, by SAS criterion, we can write triangle ADO is similar to triangle BCO. Hence proved.